Welcome, geometry students, to section 8.2, special right triangles. We're going to learn about the various types of special right triangles and how to use them, and we're going to understand why they are useful and easy. Now, the first thing here is I added these degrees here. What this means, 45, 45, 90, this is our first one, is 45 degrees, 90 degrees. As you can tell, that adds up to 180, which is the sum of a triangle, the interior angles of a triangle. Now, here we have this side here that's labeled S for side, and this side is going to be exactly the same. Why? Well, because we have this 45 and this 45 are equal, that means this is an isosceles triangle. These sides are equal, therefore that is also side. These we call the legs of the triangle. So this blue one is called the hypotenuse. The hypotenuse is always opposite the 90-degree angle. The blue here is representing the 90-degree angle, and it's always opposite the hypotenuse, okay? Now, we know that the sides of a triangle, here's the side, and the hypotenuse, have a special relationship, a squared plus b squared equals c squared. Okay, so we're going to go ahead and take that relationship over here. So we know that a squared plus b squared equals c squared, where c squared is the hypotenuse. So with using this terminology here, we know that the two legs squared added together will equal our hypotenuse. How can we simplify from here? Well, we would have 2s squared, 1s squared plus 1s squared equals 2s squared equals h squared. Okay, and just in case you're lost on what we're doing, I'm just trying to show what is the relationship between the hypotenuse and the leg. Okay, this is the important thing about these automatic triangles, these special right triangles, is they have an inherent relationship that we don't need to use the Pythagorean theorem to solve for. We can just look at it as sight recognition, okay? So I'm trying to discover that right here. So what I need to do next is get h by itself by taking the square root of both sides. Once I get that, I get the square root of 2s squared equals h. Okay, I can split that up into the square root of 2 times the square root of s squared, and that equals h. Now, what happens here? Well, I'm going to do two more lines. Here I have the square root of 2, can't simplify that, but here I have s, square root of s squared is just s, but I need to rewrite it so the s is in front and then the square root of 2 is next. In other words, if I take my leg s and I multiply it by radical 2, it will be equal to my hypotenuse. That is using Pythagorean theorem to use sight recognition. And now I have a relationship between these two parts of a 45, 45, 90 triangle, okay? The hypotenuse is equal to the leg times the square root of 2. By the same token, I can take the hypotenuse and I can divide by radical 2, and that is going to be equal to my leg. Keep in mind, though, if you divide by radical 2, you're going to have to rationalize the denominator because you can't have a square root in the denominator. Let's take a look at examples and why it's useful. First thing here, we recognize we have 45, 45. That means we have an isosceles triangle, and one of these 45, 45, 90, here's the 90-degree angle, special right triangles. So we already know that this is 9. Okay. Now, what we could do is we could go 9 squared plus 9 squared equals x squared, and we could solve. Or we could recognize that this is a leg, and this is the hypotenuse, okay, as we'd need for that. We'd need that for the Pythagorean theorem. But we could recognize that we just take one of our legs and multiply by radical 2, and we'll get the same thing. So I know I could just call this hypotenuse 9 times radical 2, or just, you don't need the dot there, 9 radical 2, and that would be my hypotenuse's length. Just so you are aware, if this was 81 plus 81 equals x squared, and I wanted to get the same thing, here I could rewrite this as 2 times 81 equals x squared. Okay, here I would take the square root of both sides. I would have square root of 2 times the square root of 81 equals x, and the square root of 81 I know is 9 times radical 2 equals x, 9 radical 2. I get the same thing if I use Pythagorean theorem, but which one's more work? Obviously this one's more work using Pythagorean theorem, and that's why understanding how the parts of a 45, 45, 90 triangle relate to each other makes it a lot easier. Okay, in this case, same problem, 45, 45, 90. These are equal, but I don't know the leg. Okay, the legs are both x, but we know the hypotenuse. We know, though, the hypotenuse divided by radical 2 will give us our leg. So we just need to input that value there. We know our leg is 10. We know we have to divide by the radical 2, and we know it's equal to x. X is our length of our leg. Now, here's the deal. Anytime you have something divided by a radical, you have to rationalize it by multiplying by radical 2 over radical 2. That's the same thing as multiplying by 1. Square root of 2 divided by square root of 2 is 1, and therefore it doesn't change the value, so we can do that. Okay? Go ahead and take a pause if you want to see that a little bit more clearly. Okay, I'm erasing. Now, why do we do that? Well, because we get in the denominator square root of 2 times square root of 2 is going to give us 2. In the top, we have 10 radical 2. We can simplify here by crossing out the 10 and the 2. They're divisible. And we have 5 in the top, 1 in the bottom, or just simply 5 radical 2. And that's our answer. So it goes from 10, the hypotenuse, to a leg being 5 radical 2 equal to x. So that's our first one. That is 45, 45, 90. Most people seem to like that one. This is the one people don't like. Okay? This is the 30, 60, 90. Obviously, he's talking about 30 degrees, 60 degrees, and 90 degrees. That adds up to 180 also. Now, we have to identify a little bit more parts here. The other one, we just had legs that are equal and then a hypotenuse. This one, we still have an hypotenuse. But now we have two different size legs. The smaller leg is going to be the one that's opposite the smaller angle. Okay, so there's the 30-degree angle. The 30-degree angle points to the shorter leg. Okay. Now, the 90 is obviously the biggest angle. Okay, that corresponds to the hypotenuse, as always. But then we also have the 60-degree angle, and that's going to correspond to the medium leg. Okay, so the opposite one there. So that's the medium leg. It pairs up with the medium angle, which is 60 degrees. Now, what's the relationship here? Well, whenever you're doing these problems, you always want to identify the short side first. Okay, we already have the short side, okay, or you're looking for this short side here, the shorter side, the shorter leg, the short leg, however you want to say it, the smallest leg, okay? That's the one you want, the one opposite 30 degrees. So the one opposite 30 degrees. Now, if we wanted to use the Pythagorean theorem proof, we could do that just like before. I'm going to spare you the proof right now and just give you the relationship. Okay, so the relationship here, in this case, is the hypotenuse is double the shorter leg in a 30, 60, 90 triangle, and it's the shorter, in the medium leg, is the shorter leg times the radical of 3. Okay, let me run that by you again. To get the hypotenuse, okay, here's the hypotenuse. In order to get the hypotenuse, we would multiply the shorter leg by 2. We would double it. Okay, so the hypotenuse is 2 times the shorter leg. For the medium leg, in order to get that one, we'd have to take the shorter leg and multiply it by radical 3. Now, this is best when done with an example, so let's go ahead and break it down in example 3. First thing I should do is identify all my angles. Okay, if that's 30 and that's 60, that means that has to be 90. Okay, so guess what? This is my long side. That's going to be my hypotenuse. Here's my medium angle. That means that's my medium side. And then here's my smallest angle, 30, so there's my short side. Okay, I'm going to call this short side. I'm going to call this one the medium side. And then there's my hypotenuse. Always important to label. Okay, now, I already know the relationship. The key is, again, you want to identify that short side. You want to find that value because you're going to use it to find the other two sides. What's the relationship? Well, to find my hypotenuse, I'm going to take my short side and I'm going to multiply by 2. Short times 2. Well, I know my short side. It's 4. So 4 times 2 will be equal to my hypotenuse. So my hypotenuse equals 8. Okay. Now, let's move on to the medium side. The medium side, we know the medium side is just equal to the short side times radical 3. So I'm going to take 4 and I'll multiply it by radical 3. So my medium side is 4 radical 3. That's my medium side. So I can go ahead and write that in. 4 radical 3, and I'm done. That's all there is to it. That's how we can do it quickly. It's way easier to do it that way. Now, the other cool thing about this, understanding 30, 60, 90, and 45, 45, 90 triangles, is we only need one side to find all the other two sides. Whereas if we have the Pythagorean theorem, how many sides do we need? Well, a squared plus b squared equals c squared. We need at least 2 of the 3. Doesn't matter if it's a or b and c, or a and c. We need at least 2 of the 3 in order to make it work. Where if you understand the relationships with 30, 60, 90, and 45, 45, 90, then you just need one side. As we have in example 4. This time we're given the long side. Okay, here's our 90-degree angle. So it's opposite. This is our hypotenuse. Okay, here we have our medium side. And then here we have our short side. Now, the key is always find the short side. You always want to find the short side first. Well, we know that our short side times 2 equals the hypotenuse. This time we have the hypotenuse. We know it's equal to 10. We want to find the short side. It's called a. And we know it's times 2 to get to the hypotenuse. So now we just solve for a by dividing by 2 to both sides. A equals 5. We take 10 divided by 2 and we get 5. Okay? I know this is my short side, by the way, because it's opposite the 30 degrees. Now, once I have my short side, I plug it into my formula for the medium. So I have short times radical 3 equals the medium. Oops, wrong color. So I know my medium is equal to 5 times radical 3. 5 radical 3 is equal to my medium side. So I just take this, multiply by radical 3, and I'm done. Example 5, last one. Okay, the first one we're given the short side, the second one we're given the hypotenuse. This time we're given the medium side. Okay, this one's the toughest, honestly. So here's our medium side. Let's identify our short side. There's our short side. And our last one is our hypotenuse there. Okay, the key is always finding the short side first. Okay, so I know my medium side is equal to my short side times radical 3. Well, I know my medium side is 6. I don't know my short side, but I call it m, and I know it's multiplied by radical 3. So the first thing I need to do is, if I'm multiplying by radical 3 and I want to undo it, I got to divide by radical 3. So I know m is equal to 6 divided by radical 3. I have to rationalize this. This is the part people don't like. You multiply by radical 3 over radical 3. You multiply by whatever's in the denominator. And I have a video on that, okay? So if you need some help, check it out. All right, so this is equal to 1, so we can multiply it by 1, and we're good. We have no problems there. So let's go ahead and do that. First, I start with my denominator. Square root of 3 times square root of 3 equals 3. That's why I did that. Now I have 6 times radical 3. You're always going to be able to reduce, or most of the time you should be able to. I know 6 goes into 3 2 times, 3 goes into 3 1 time, so I have 2 radical 3 over 1. That is equal to m equals 2 radical 3. So that's my answer for my short side. Let me change that to red, actually. Oops. Oh, that's m, so I got confused. I was thinking that was my medium side. I was like, what? I thought I did this correctly. Let me change this color. I'll change this all to red. I hope you guys know where I canceled. There we go. Okay, so m equals, that's my short side. Very confusing. 2 radical 3. Okay. Now, from here, this is the easiest part, is we know that short times 2 equals the hypotenuse. Okay, so I just take my short side, which is 2 radical 3, and I multiply that by 2. Now, how do we multiply those radicals? We only multiply the numbers out in front. So we get 4 radical 3, and that is equal to my hypotenuse. You double the number out in front. So we get 4 radical 3, and that's equal to n, and I'm done. That's all there is to it for 30, 60, 90 and 45, 45, 90. Stay tuned for more videos on this exact same topic. This one's kind of challenging, but make sure you master this. Will really save you some time in the future. Thanks for watching this video. Hope you watch some more in the future.